Alrighty, this is fourth video of network and security data class. I'm going to discuss about procedures and protocols when developing, deploying, and maintaining program code. So let's go. So first point is articulate wireless security. What is it? What is wireless security? Wireless security is the prevention of unauthorized access or damage to computers using wireless networks. It is delivered through wireless devices like router or switch. Hackers cannot view the traffic content in transit, even if security is compromised. Also, wireless intrusion detection and prevention systems provide protection by alerting wireless network admins in case of security breach. So, there are three types of their security standards, and there is difference between three WLAN security standards. Well, as wireless network technologies have evolved, so too have wireless security protocols for securing them. Wireless security passwords are the only half battle. Choosing the proper level of encryption is just as vital, and the right choice will determine whether your wireless LAN is a house of straw or a shielded fortress. So let's see detail about all three WLAN. So let's look at first one, WEP, which is wired equivalent privacy, and first 802.11 security standard, easily hacked due to its 24-bit initialization vector and weak authentication, of course. And how does that work? That uses RC4 stream, cipher, and 64 or 128-bit keys. Static master key must be manually entered into each device. Should you use it? No, because again, small IV size increase the likelihood that keys will be reused, which in turn makes easier to crack. This characteristic with several other vulnerabilities, including problematic authentication mechanism, make WEP risky choice. So that forced everyone to move for a better choice, which was WPA. So which is Wi-Fi protected access. So let's look fast facts about that. So there is an interim standard to address major WP flaws, backwards compatible with WEP devices. It has two modes, personal and enterprise. How does that work? That retains use of RC4 but adds longer IVs and 256-bit keys. Each client gets new key with TKIP. So what is in enterprise mode? That has strong authentication via 802.1x and EAP. Should we use it? Well, yeah, but there is also a better option available, which is WAP. So what is WPA? So that's current standard. Newer hardware ensures advanced encryption doesn't affect performance. Also has personal and enterprise modes. So how does it work? That replaces RC4 and TKIP with CCMP and AES algorithm for stronger authentication and encryption. Should you use it? Yes. So I'm going to discuss more about WPA. There was introduced more seamless roaming, allowing clients to move from one access point to another on same network without having to re-authenticate using pairwise master key, caching, or pre-authentication. So up till now, WPA2 is still a better choice among all three. So now let's move to AP switch hubs routers. So hubs that can send or receive data but cannot do it both at the same time. They cannot identify source of info it receives, so it sends info to all computers connected to it, which is not safe. Switch. They are faster than hub. They can also send and receive info at the same time. They are best to use for home and office where network activity is used for passing info between one or more computers. Routers. They are known as intermediary devices, capable of directing network traffic. They can be wired or wireless and provide built-in security such as firewalls. Access points provide wireless access to wired Ethernet, plugs into hub, switch, or wire router and sends out wireless signals, which enables computers and devices to connect to wired network wirelessly. For example, connecting to wireless network in airport, hotel, public are usually connecting through AP access points. So when we look in detail about all these four sections, all we know is like access points, they are the most convenient way to use convenient way in comparison with other three. So let's move to the next slide. So now we are going to explore more detail about firewalls. So what is it? A system that is designed to prevent unauthorized access to or from a private network, which can be implemented in either hardware or software. It can block traffic intended for particular IP addresses or server ports. What are the types of firewalls? First is packet, which is this is the original type of firewall that operates inline junction points where devices such as routers and switches do their work. This doesn't route packets but compare each packet received to a set of established criteria like IP addresses, packet type, port number. Packets that are troublesome are not forwarded. So second type is proxies that filter messages at the application layer. They filter packets according to the service which they are intended as specified by destination port and certain characteristics such as HTTP request string. Stateful inspection not only examine each packet but also keep track if a packet is part of established TCP session. This offers more security than packet filters but exacts a greater toll on network performance. So 4.3 topic is examine NAP, network access protection. It is a Microsoft technology for controlling network access of a computer based on its health. In other words, NAP determines if a remote client computer meet IT policies before they are granted access to the corporate network. NAP was deprecated in Windows Server 2012 R2 and is going away, but we could use health attestation features of Windows 10, which is cloud approach in managing compliance. NAP importance has been faded with recent rise of public clouds. Microsoft is now spending much more resources supporting BYOD, which is buy your own device, bring your own device scenarios. Microsoft IT uses Intune to make BYOD easy and secure. That's last and fourth topic, which is exploring network isolation. So I have discussed air gapping in one of the previous slide from one of the video, which is air gapping again is a network security method employed on one or more computers, ensuring that secure computer network is physically isolated from unsecured networks. How do we isolate sensitive servers? Firewalling, which is basic way to give degree of isolation, mostly protection against direct attacks on server. Virtual network segmentation, subnetting. This makes it little more difficult to get access to computers, but still not impossible. IPsec. This is strong integrated network security mechanism that works at packet level. Packets are encrypted and only exchanged between server and trusted clients. IPsec big benefit is verification. Use its own built-in authentication scheme, Kerberos. Clean room. There is isolated computer behind locked doors. Such machines have control over hardware or software, should not allow software to be installed or new hardware devices without admin access. So this is all about part 4 of the video, and And this is all I'm covering for this. Please do let me know in case if there is anything which I'm missing. I'll be more happy to modify my slides or videos for future purpose and learning more about it. And that's it. Thank you.